Hello. Welcome back. Let's check out the wisdom of the crowd today. Now keep in mind that quizzes can't reduce your final grade, only improve it, and that I will drop some of the worst quizzes. I haven't decided how many or what criteria there will be, but don't give up just because you've done bad on a few. There will be some curving happening at the end with the quizzes. Alright, so for the most part, look at that average. I got 27%. Not great. This is expected to be a really hard one since you've only just seen all of these yesterday, but you should expect a lot more little short ones like this. A lot of requests in the Discord to just give everybody an A in this class. Tell you what, I will think about it, and I'll get back to you in about 15 weeks. Does that sound fair? Yeah. Sounds fair to me. Alright, so the code, let me have a look at that. I just retyped it real quickly. We want to know if entry, length, and num records should be basically private, public, or static, or some combination thereof, those three things. And we want to know which ones should have getters, which ones should have setters. So we figure that out. Alright, well, it looks like most people didn't say none of them, which is good. That was the only easily wrong answer. And then the one that looks like the most people got wrong was that static one. So let's go over these and think about the logic. All right, so you're going to probably want access to all three of these values. If you're looking at records and you want some information of them, about them, then you're probably going to want access to all three of these. So the fact that they're going to have getters is kind of a given. The question is whether or not they need a getter or whether or not we can just make the field public and make them accessible directly. So let's think about what would happen if we made entry public, for example, and you were able to edit entry from outside of this class. So you were able to edit the text of entry in the outside of the class driver, for example. If you could just say entry.text equals, what would be the implication of that? Well, if you could do that, if you could just set entry equal to whatever text you wanted to, then you would update it without updating the length. And the terms of the quiz said that the length variable there always has to match the length of the entry. So you're going to need a setter, at least, in order to set the entry to be some text and then also set the length at the same time. So it would be something like this. I'll just take a string called s as an argument. So you would have to do something like that in order to set the length and the entry up at the same time. Somebody asked if we have this code anywhere. No, you don't. So there was only an image on the quiz, so you had to retype it. But you don't really have to retype this or anything. It's just for, review purposes. And really think it's going to help you to have this. It can't even run because it doesn't have a driver or anything. So if you want it, I'll upload it to Canvas, but it's not going to help you really. So I'll just upload it at the end anyway if you want to see it. Alright, so you would need some kind of setter like that in order to make sure that anytime you change the text, the length would also update. Otherwise, you could change the text and the length would go out of date. That means that both entry and length are probably going to be private. And the reason that they're probably going to be private is to make it so that you can't accidentally set one of them without setting the other from another class. So if you were able to do that, you might accidentally change the length or the entry without changing the other accordingly. This way, the only way to change the entry's text is to do it through the setter. Now you might say, well, isn't this also like a setter for length as well? And I guess you could argue that. But semantically, this is obviously a setter for the entry. You're actually just setting the text. The length just happens to piggyback along with the same setter. So you can justify your answer if you said that length also gets a setter too. But basically, we're talking about setting the entry there, and length just gets set in that process. Let's see what the next question was. So which fields should be private and have a getter method? The answer to that question deriving from the answer to this question is going to be all of them. What we just said about entry, the fact that you shouldn't be able to change it directly, that's also going to be true for the number of records. The number of records should only update anytime a new record gets made. You wouldn't want anybody to change it manually, or the count is going to become obsolete. So you want to restrict anybody's ability to edit the number of records beyond the editing that this class does whenever a new record is created. So you're going to restrict that by making it private. And that means that since all three of these are private, if we want any kind of access to them, which it's specified in the details that you do, you're going to want to write getters for all three of them. So we're going to have a get entry that returns entry, and then we'll have a get length, or the more conventional name for this method that you'll see in all of your different classes that implement a kind of length. They'll just call it length. So you might have noticed that so far this is very similar to a class you're already familiar with, string. This is basically how string works, right? Anytime you change the text of a string, it also updates the length variable. It accesses a setter very much like this, and it has a getter for length very much like this. I'll just call this get num records. Okay, so that answers that question in a few parts. The fact that all of them need to be restricted in order to be edited correctly, the fact that there's a particular way that they all need to be edited that shouldn't be done directly in any case, that makes them all have to be private, and then the fact that they're all private means that you need a getter in order to access them. So the answer to the first question is all of them need a getter. Now, which field should have a setter? We already kind of answered that. The only one that needs to be set directly is the text, the entry. When you set the text, it also sets the length and everything, so that's the only one that should have a setter. So the answer to that one is that just entry needs to have a setter. And then which fields should be static? This is a harder question, right? So which field should there be only one copy of that all the records that are created shared? Well, when you increment the record count, right now the record count belongs to a particular record. So if we made a new record, we would have a record count. It starts at 0 up here, and then we would add 1 to it. We would make it 1. But that's probably not what we want to do. We want the record count to track the total number of records that have been made across all the different records that have been made. So this is the variable that's supposed to be static. All right, this is the variable that's supposed to be static. And then you probably want to make the get num records method static too, which I didn't ask about. We haven't looked at static methods yet. And generally, you want to make a method static when it deals with static variables. And the reason you do that is so that you can access the number of records without having to refer to a particular record. You just refer to the object's name or class name or its template or whatever you want to call it. You can just say how many records there are. So every time a new record gets made, it adds 1 to that static variable, and since they all share the same static variable, when a new record gets made, it adds 1 to it. When a different record gets made, it adds 1 to that same variable. Since it's shared among all of them, it'll just increment every time a new one is generated. And since that only happens in the constructor, there's no other way to increment how many records are made. We made it private, so it's not accessible to be changed from outside of this class. So that's basically how you would organize this. Some of this probably up for minor dispute, but that's the answer there. So the only one that should be static is the number of records. Obviously, the entry and the length are unique to every single record generated. They all have their own text, and all of that text has its own length. And we'll just do some more of these over the coming days, so hopefully you get familiar with public, private, and static as we go. It's one of those things that gets more obvious the more times you do it. At this point, let's pick up the bug that we left off on last time. Last time we had a bug where after we ran our program here, it was supposed to print out that it didn't update the secret for A as well, because we thought that the value for A was 10. In fact, we made our assumptions clear here. We said that A's value is 6, B's value is 10, A's secret value is 10, and B's secret is 15. So just to space those out again. That's what we thought was true. So I went back and I printed, before we actually set the secret value, I printed what they actually are. So I printed out the secret value and the value that we're going to be dealing with. All right. And when we run this, you see that, going back to how we invoked it in the driver, the first time when you call dude_a.setSecretValue and set it to dude_b.value, it's trying to update it to 10, and it sees a 6. And then the second time it's trying to update it to 6, and it sees a 10. So this dude_b.value ends up being printed first there, so it's the 10, and then the second one is the 6. So if you lost track of that from last time, that's okay. The real thing that I want to demonstrate here is what the bug is, why this happened. So remember, I let Eclipse automatically generate the setters for me when I changed secret value to a private in order to restrict its access from outside the class. When I did that, it offered me to make getters and setters. I accepted, and it made them down here. Okay, and then I customized the setter to do some extra stuff. It would only set the secret value if it was bigger than the existing value. Otherwise, it wouldn't do anything, right? And what happened when I did that was that it also changed this line here, which used to be this. Yes, it used to be that. It changed it to this instead. It changed it to this setter invocation down here. And that introduced a bug, right? So when it sets the secret value now, it does this check, which I didn't used to do before. And since I didn't used to do that before, it didn't used to be a problem. But now, if you look at when a is instantiated in the first place, I pass 5 as the value and 10 as the secret value, right? So you go for 5 as the value, 10 as the secret value. It ends up setting the secret value to 10. It ends up setting the value to 6 and the secret value to 10, which is not what we were expecting. And so we introduced a little bit of a bug there. So just something to keep in mind, that when you update your references to that auto-generated setter, occasionally you can introduce an error there. So I'm going to clear this stuff out, everything related to the bug. We're just going to assume that that's the way that it was supposed to work. Also wanted to point out a good way to debug when you have these kinds of issues is to just print out all the values that you're considering. So I added this little print statement here to make that a little bit more straightforward. We'll do that again in the future too. All right, so getting rid of all of those and getting rid of the question. The answer is make sure to be careful when you auto-generate getters and setters. Or just do it from the start, and then you don't have to worry about it updating things further down the road. A lot of people's default choice is to make everything private and then don't make it public unless there's a compelling reason to do so. And some people go the other way around. They make everything public and don't make it private unless there's a compelling reason to do so. Okay, so just to quickly review what the doodads are. So remember, it's an object that has a value, a secret value, and an initial value. The initial value is just set to whatever the value is at the start. And then the shared value is shared across all doodads and starts at 2. And we did some modifications to all those different things in the driver. So here's a question. If I do this, if I do int value equals 3 up here in the declaration when I first make the field, and then in the constructor I set it to something else, what does it end up being? So if I set it to 3 up in the field, and then I set it to something else in the constructor, what do you think it's going to end up being? I'm going to take a poll. So does it end up being the 3 that we set it to up there? Does it end up being the value that we set it to in the constructor? Or does it end up being something else entirely? So this is basically a question of what happens first, the field declarations, the constructor stuff, or does it do some other thing where the order isn't completely clear? So most people are answering whatever is in the constructor, which is the right answer. And we can tell because when we made doodad A and doodad B here, we set their values to 5 and 10. All right, and we can see that when we run this, when we printed them out here, they do indeed have an initial value of 6 and initial value of 10, or initial value of 5, I guess, current value of 6 because we added 1 here, but the value is 6 and the value is 10 at the moment. So it's not 3 anyway in either case. So that's another thing I want to point out, that the fields up here, they execute first before everything else. So whenever an object is made, those fields execute first, and then the constructor executes. So whatever happens in the constructor takes precedence over whatever you've done in the fields, and then everything else can do its thing. So it's going to be the fields, and then the constructor is the order it's always going to go in. So anything you set in a field, you can overwrite in the constructor. If I didn't specify a value, if I just omitted this, then that field that I specified would take precedence, and they would indeed start at 3. A ends up at 4 because we added 1 to it along the way there. We added 1. All right, so I'm going to change that back so that I do specify it, and I'm going to get rid of this because it's unnecessary since we overwrite it anyway. Now, what about static fields? Because that's a different case, right? I have this statement here, which sets shared value to 2. Right? So you would expect that every time I make a new doodad, shared value gets reset back to 2. Why does the shared value keep increasing when I make new doodads? So when I was playing with the shared value over here, I did some stuff to it, okay? If I made a new one, call it C, value 7 and a secret value of 14, is that shared value going to be reset to 2 because all those field lines at the top executed? Let's see. I'm going to add a little line here so it's clearer in the console. So call it after C. It's 7, and it was 7 before that as well. So the static lines follow a different set of rules. The static field declarations for an object, so any field declaration that has static in it, those actually all happen when the program first starts. So those are created when the program first launches, and those don't happen every time you create a new doodad. That means that the static values don't get overridden. It'd be really annoying if every time you made a new object, those static values got overridden, and it lets you specify their starting value in the field up there. I'm going to take a poll in response to a question in Discord. Somebody wants to ask questions in the voice channel. I'll take a poll on Canvas maybe later and see if that's something that a lot of people are interested in. Let me do a poll. So one thing to note before you vote is that there is a bit of a delay between Discord and the YouTube live stream, so you'd be asking questions on something like a 10-second delay. Interested in asking questions live by voice chat. We'll probably follow this up with a Canvas survey later. Alright, so that's it for Doodad for now on the specifying the fields thing. Something to keep in mind when you're debugging mistakes where maybe you set something in a field and then you didn't realize it down the road, that it got overridden somewhere in the constructor. Now let's go on to Doodad Processor, the other class that we made here when we first started all of this stuff. And here we're going to practice using an object in a different class. So we already made this Doodad object. We played around with using it in driver. We have all these different things we did with it in driver. Now let's play around with using it in another class. And one of the things I want to point out today is that you can, just like any other variable, make arrays of objects. So in the Doodad processor class, we're going to make an array of doodads. And the syntax for that is the same as an array of anything else. You specify the kind of object you want, in this case doodads. You put your little brackets. I'm going to call this doodads. And then you have to use, just like when you specify arrays of integers or strings or whatever, that keyword new, the name of the object again, and then how many you would like in the array in the brackets there. So I'm going to make this an array of 10 doodads. So what is the starting value of all of the doodads in this array? Let me ask that. If you know in either chat, let me know. What is the starting value of all the doodads in this array? I'm going to give you a hint as well. Imagine it was this, because string is another kind of object. What would be the starting value of all of those strings? So somebody said 0. If they were integers, that would be the right answer. But doodads can't have a value of 0. Doodads have all these different properties like value and secret value and initial value and shared value. Objects might have many other properties. They also have name and different things like that. So what's the value of an object, all these different properties? Null is the answer, as some people answered in the general chat. So strings and objects, if they are not instantiated, they have a value of null. So anytime you have a reference to something that's not instantiated, if you had a single one, something like that, but you didn't have the right-hand side of that expression completed, that would also be null. So the value of this guy before they get instantiated is null as well. And when you create an array of objects, you don't specify any kind of instantiation. Remember that in order to make a doodad, you need to invoke its constructor, and its constructor takes those 3 arguments, the name, the value, the secret. We haven't done that yet, so this whole array is full of null doodads. So you can think of it more as an array that has a bunch of spots available for doodads, none of which happen to exist yet. And now let's look at a way that we can make objects in different ways. So we looked at last time the constructor, which is like a special kind of method that has no return type and is executed when the object is first instantiated and then not again. So whenever you first make an object, the constructor happens. It doesn't return anything, so it's not even a void. Technically, a void returns nothing, which is not really an important detail, but it doesn't matter. A constructor doesn't return anything. It's just executed, and then the object is created after that. So that's the constructor. Somebody asked, when we create a class, will we normally do this.variable equals variable? So that's up to the programmer and how you want to do your naming conventions. So when we do a constructor for Dodat processor, and let's say we take a couple of arguments. Let's say we want one constructor that makes doodads in a random number range between low and high. So this is going to create a doodad processor that has 10 doodads with value and secret value between the low and high range, chosen randomly. That's the goal here. Sometimes I like to do this. If you can do it, I recommend that you do it. Write the comment before you write the code, and then make the code match what you believe it should do. It can often help you to write the documentation ahead of writing the code, because now you know what it is that you have to do. If you want to be real fancy here, you can also do add link and link to the doodad's value here, but it's going to be difficult because you have to go like doodads dot value doodad dot value, something like that, in order to get it to actually show up the link. Let's see. No, that's not right. Anyway, it's harder to link between classes. I always forget the syntax, so I usually don't if it's between classes like that. But if there's a compelling reason to see it, or you just want to make nicer looking documentation, you can do the between class link there in your documentation too. Okay, so we want this to be done. In this case, there's no this.variable equals variable to set up, right? We don't have a low and a high in this class to store. So in this case, no, the constructor doesn't have a this.variable that we need to set up. Going back to Doodad's example, when we set the name, the value, and the secret, it's up to you what you want to name these local variables. And some programmers, to avoid the use of the this keyword, just name them something different. So you could just as easily do what we did with secret value and name it something different than what it is at the top. Rather than secret value, it's just named secret. You could do the same thing with name. You could name it n instead of name, and then you can just say name equals n, and it can infer that you're looking for the field name, the one at the top. See, it stays teal, the n stays blue. That means it knows the n is local. The teal is the field at the top. But typically, it's less confusing when you recycle the same name, which I know is a little bit counterintuitive from the get-go. And the reason that it's less confusing is because you don't have to waste all of the cognitive bandwidth thinking about what to name your different variables. So if the field name is name, what am I going to name the local one? I'm going to name it n or something. All right, what if I already have another n? Then what do I do? You know, it's complicated at that point, right? So the easiest way to do it, just to name the local variables the same thing as the field, and then do the this dot. It makes it much less ambiguous, I think. But both ways are fine. If you want to name your local variable something different to avoid the use of the this keyword, that's fine as well. And yes, somebody's error there on Canvas. It looks like you're trying to work on class Dodat instead of class Dodat processor, or at least you've named your class Dodat instead of class Dodat processor. We're working on, remember when we first made this, we made 3 classes, driver, Dodat, and Dodat processor. This is that third one. So if you look at my package that I'm working in, there's 3 classes in there. If you have forgotten how to make a class, by the way, remember you right-click on the package, go to New, go to Class, generate the class that way. Okay, so let's actually do this. Let's do what the comment describes. We're going to make 10 doodads with values and secret values between the low and the high range. So how do we loop through this array of doodads and make new ones? Well, the same way that we would loop through any other array. So I equals 0, I is less than doodad.length, I plus plus. We can access the different doodads in there now. Doodads of I. So this is a reference. A field name is new doodad. And then remember, we have 3 things to specify in the constructor. Its name, its value, and its secret value. We haven't designated what we're going to give it as a name. So what should we give it as a name? Create a doodad that has 10 doodads with values and secret values to the high range, chosen randomly. Let's say name is a random letter, a random capital letter from A to Z. Okay, so let's pull that off as well, an extra little thing. How do we pick a random capital letter from A to Z? There are a lot of ways to do it. One way you can do it is to create a string, A to Z. It's fine. See, I've broken my naming rules a little there by starting with a capital. I guess I can call it A to Z. It's a little bit confusing because then it doesn't make it clear that it's a capital. So up to you when you run into weird situations like that. And I'm going to make that A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Hopefully I didn't miss any there. Okay, so that's all the letters in the alphabet. Now let's pick a random one. How do we pick a random letter from a string? How do we pick a random letter from a string? So string name equals, and then we're going to pick a random letter from the string. So it's going to be A to Z, and we're going to pick a character at some index, and we're going to choose that index randomly. All right, I have another error. Let me see. I think you have still named the constructor differently from the class. I think your constructor has a lowercase letter instead of an uppercase. All right, so if I want to pick an index between 0 and the last one available here, remember last time we looked at actually I think on the first day we looked at generating a random number, And I want a number between 0 and the last possible index here, so it's going to be between 0 and a to z length. That'll give me a random index. Now this is supposed to be an integer, because integers are required for char add. We can't use doubles like math.random. And then this whole thing is supposed to be a character, according to our cast here, but we actually wanted a string, so can we do this? Can we just cast it to a string? No. Can't cast from char to string, right? What if we did this? What if we did make it character like it recommended? Let's see if this will work. Okay, anybody confused about what we did there in order to pick a random letter of the alphabet? I wrote a string that has all the letters of the alphabet. Then I picked a random index between 0 and the last index there. And then I took the character at that random index in my fully typed alphabet expression. One way to do it. Okay, we're also going to pick the value the same way. We're going to do math.random, and we're going to pick a range between low and high. What should the expression be if we want to pick a range between low and high? Well, let's think about that. So we can use math.random, which gives us a random number between 0 and 1, and we want a number between low and high. We want a number between low and high. I'm going to just leave this as a placeholder for now. While you think about it, if you have the answer, post in either chat. We want a number between low and high. So this is wrong what I'm putting here. I'm just putting it as a placeholder until we have an answer. We want a number between low and high. And so let me supply all of these to our constructor in order to create the doodad, and see if that checks out. Is it okay with taking a character? No, it's not. So what do we do? Well, we can change name to string, and then it's going to give us this error again because of that. So what do we do in order to convert the character to a string? Let's see if I have any answer for the first question, though. So somebody said random, I'll just copy it in. Somebody said they want to do random times high plus low. Alright, so let's do the math here. Let's say that low is 5 and high is 10. This equation gives you 0 to 1 times 10 plus 5. So the range that this gives you is going to be basically between 5 and 15. So if the 0 rolls to a 0, we get 5. If the random rolls to a 1, then we would get 15. But we want between 5 and 10. So close. A little bit of an edit there. So somebody else posted another recommendation. Let's try that one out. It's going to be low plus random times high. So again, if we say low is 5 and high is 5, and high is 10, then this equation gives us 5 plus, and then a range from 0 to 1 times 10. So this is the same thing again. It's 5 plus, if it rolls a 0, then we end up with 5. If it rolls a 10, then we end up with 15. So we've got, again, a little bit larger than the range we're looking for, between low and high. All right, I saw the answer there. Let me copy it. Anytime that you want to do a range like this, it's going to look something like that. You're going to do high minus low times random, and then plus low. We reviewed that really quickly last time, so just keep that in mind. Anytime you want to do a range, it's basically high minus low times the random plus low. This gives us 0 to 1 times, it works out to high minus low is 5, and then plus 5. So that obviously gives us, if it rolls a 0, 5. If it rolls a 1, we end up with 10, which is the range that we're looking for, that 5 to 10 range. So this is the correct answer for getting a range between high and low, or low and high. So if we're getting a range between low and high, remember high minus low, random 0 to 1 times high minus low plus low. Annoying auto comment format, but that's okay. I'll show you later how to turn off the auto formatter for specific areas if you don't like it. I guess for now we'll just omit that. All right, and I wanted both of these numbers to use that random value. Now let's fix the object declaration. It expects name to be a string. So what can we do? Well, we could convert it to a string, I guess. Name as string. It could be like name dot, what do we got here? Nothing. So we would have to use the wrapper class there. Character dot to string name. That would do the trick, right? That's a little bit wordy, but that works well enough. If you want, in either chat, come up with a smarter way to do it. A smarter way. Remember, all we really wanted to do was pick a letter from the alphabet here. So this is pretty convoluted. How can we do that? So picks a random letter from the alphabet specified above. Alright, and all this was to the point of creating a new doodad with that randomly generated name, that randomly generated value, and that randomly generated secret value. And remember, all this is happening inside of a for loop, so we're specifying 10 doodads by doing this. We're specifying 10 doodads by doing this. But let's say that you want the doodad processor to support other ways to make doodads besides making them in this weird random number generation thing. You are allowed to make as many constructors as you want as long as they have different arguments. So this is a little bit unusual because we're used to only being able to make one method of each name. Probably that's all you did in 128. You only made a single method with each name. We're going to see that's not necessarily the case either, but with constructors as well, you can make as many as you'd like as long as they have different arguments. That means that I've already made a constructor here that takes 2 integers, so I can't make another one that takes 2 integers. But I can make a constructor that takes, let's say, nothing. Let's say that we can make a doodad processor that takes no arguments. And what should it do in this case? Well, that's up to you. I mean, you can do whatever you want in this case. So I'm going to say that with no arguments, creates a doodad processor, like this 2 words, a doodad processor that has an empty array of doodads. So they're all null. I guess we can even specify if you want, all null. Alright, so that's what I want to do if it's no argument constructor. And I don't have to put anything here because that's already been done. We did it up here in the field declaration. Sometimes you want to specify the length, maybe, of the doodad processor. So you might be able to do that and move your instantiation statement for the array down to here. It doesn't necessarily have to be in the fields. You could move it to the constructor too. We'll look at an example like that down the road as well. Okay, so I've got the blank constructor. What else might I want? Well, maybe you already have a specific array of doodads in mind. So let's create a constructor that takes an array of doodads like we already have and sets it to the one that we're looking at. So a constructor that takes an array of doodads. We could do something like that. There's no guarantee that the array that we get is also length 10, so this could completely change the length of our array here. So that's an interesting one to have to support. And so forth. So any kind of different constructor that we want to make with different arguments is fair game. Let's look at a couple of support methods that we might want to use on this kind of thing. So how could we add items to the Dodat array if there's room? So let's say that there's a null spot available and we want to add something to the Dodat array. I don't know if you've done this at all in 128. Hopefully you have, adding individual strings to maybe an array of strings, or swapping an integer in an array of integers for another. It's a little bit different with strings and other objects, right? Because rather than having a placeholder value of 0, there's this placeholder value of null. And if we try to do something on a null object, like a null string, for example, we're going to run into an exception. So let's write a method to add a doodad. So add doodad. Of course, you need to take a doodad as an argument. I'll just call it d. Or, I don't know, let's be more specific. We'll call it to add. All right, and this is going to add a doodad to the array if there is room. If there is room. If there is not room, prints an error and does nothing. Adds a doodad to the array if there's room, and if there's not room, it prints an error and does nothing. So in order to do this successfully, the easiest way is usually to create an integer field, private int next doodad, that tracks the index, the next index that's open. So the next index that's available. It tracks the next available index where we can insert a doodad. This leads us to a couple of updates that we have to make already in order to support this next available index. Well, by default, it's 0 because the array is empty, and 0 is the first available spot. But if we have this constructor that lets you make 10 doodads as you go, well, every time you make one, that should move the next spot up by 1. Somebody recommended to use ASCII or one of the randomizing methods that's built in order to get a random letter. Definitely do that. Definitely do that. But let's say I do want to pick a random one for my alphabet for some reason. Is there a shorter version of it than this? So every time I add a new doodad, I have to increment my next doodads by 1. Next doodad plus plus. Which brings me to issue, because now I have to do the same thing down here in the doodad processor every time I add one. Because it came in from the array, I need to figure out what the next available spot is. So how do I figure out what the next available spot is in an array that I just got? Well, I guess I can set it to the first null spot that you get. Maybe I can set it to the last index so that you can't add anything. That's going to be up to you how you want to implement it. So I'm going to set it to the last index because that's the most convenient here. So I'll set it to the last available index. And I'll specify that in the comment. It's the next spot, the last index, which means there are no spots available. That might lead you to make another constructor. What if that's not the behavior that you want? What if you want to be able to add an array of doodads and you want to specify where the next doodad should go? So perhaps we just copy this and make another constructor that, in addition to the array, also takes an integer. And rather than setting it to the length, it sets it to that particular integer. I've done a lot of copy and pasting and typing here. You definitely don't have to follow along because these are not constructors that we're probably going to use. So now it sets the next spot rather than to the last index, it sets it to the specified value. So perhaps you want to designate an array that still has some empty spots in it is the one that you're going to use. Somebody wanted me to go back to dodat.java, so we'll take a look at that again for a second. Anything in particular you want to look at? The only thing of interest to us now really are the fields and the constructor. Our constructor takes those three arguments, a name, a value, and a secret. So a string and two integers. String and two integers. All right, so back to adding doodads, which was the whole point of this exercise in the first place. We want to add a doodad to our doodad array. Let me check out that error before I go on. Let's see. So since your doodad is still underlined there, this is probably not in the same package, or the doodad class that you made doesn't have the name doodad with a capital D. So in order for it to pick up the doodad class there, they have to be in the same package. So I have all of these in object intro. I see yours says object intro for that one. Don't know about your doodad class. Now you were accidentally editing doodad earlier, so it's possible that you actually got rid of it, or it's not in the package anymore, or maybe you overwrote its code when you were working on it. So make sure it matches this, the doodad class that we made last time, and that's on Canvas as well. Okay, so how do we add a new doodad to the next available spot in the array? So first we want to check to make sure that adding one doesn't go over the length of the array. So if it's full, then we are supposed to print an error and do nothing. So how do we check if there is still room available? Well, if the next doodad plus 1 is smaller than the length, I call them doodads, then we have room available to add something. That seems accurate, right? Plus 1 is smaller than the length. We'll go back later and see if that was correct, unless somebody has a correction to offer now. So if that's the case, then we're going to add the doodad that you specified here, and we're going to use that next doodad as the index. So it becomes to add, and then of course we have to add 1 in order to designate that that spot's taken. Now we're looking at the next spot available. If there wasn't room, then we were supposed to print that error message. So this is the condition where there's no room, print an error. In addition to system.out.println, there's also another kind of print you can do, and that's going to be Cis Error. And the only difference between them is that Cis Error prints to the console in red text. That's the only practical difference between them. You can also change your console to display only messages or only errors. So some people toggle back and forth when they've got a lot of messages going on. But the main difference is that one is red and one is not. So red means bad. Good to print red when something bad happens. Doodad processor is full. So that's adding one. That's adding one. Now, the more complicated one is how to remove a doodad. How to remove one. So, first of all, what do we remove it by? Do we designate an index? Do we designate a doodad? Do we designate a name? How do we want to remove them? Well, there's different ways where we might want to remove one. We might want to remove one by value. We might want to remove one by name. We might want to remove one by the index that it's in the array. So we would probably add multiple to remove methods, which brings us to those methods that have the same name, like constructor has the same name. Let's write a basic one for now, and then we'll write some other ones later. So remove doodad. And let's remove it by its reference. Let's see how this works. Doodad dot to remove. Okay, so we're removing it by its object reference. That means you need to have an exact match. You need to have a reference to the doodad you want to take out in order to remove it. So we're going to seek it out in the array there. So we have to loop through it. we got to find it. That means a check for equality. Okay, we can do that. Remember, that's not necessarily recommended. The better way to do it would be equals to remove. But let's try it with a double equals and see if it works, since that's the more recognizable version. Okay, and how do we clear it out? How do we empty out its spot in the array? What should we do at this point? How do you destroy an object? How do you empty out its spot? Well, the answer is you can't destroy an object. You can't designate that an object shouldn't exist anymore. But there is a way that we should empty, or there is a way that we can empty out its spot in the array so that it is no longer in that Dodad's array that this processor manages. So how might we do that in either chat? How do we empty out a spot in a Dodad's array so that it no longer contains the one that we're trying to get rid of? How do we empty out the spot so that it no longer is there? Empty out a spot. While we're thinking about that, let's write another remove method that removes by some other criteria. So perhaps you want to remove a doodad by name. Perhaps you want to just find a doodad that has a matching name and remove it. So now, rather than comparing the doodad's references, we're going to be comparing something else. We're still going to loop through the array of doodads, and we're going to try to find one with the name that we want to remove. Someone suggested doodads of I equals null. That is indeed the way that you would empty out a spot in the array. So the array had a reference to that doodad, now it doesn't. And now that you don't have that reference there anymore, it's not going to be impacted by any of the different places where we're going to search for that doodad or do anything with it in the array. Alright, so notice here I have two methods with the same name, but they have different arguments. This is a common practice too. Basically, this is usually called overloading. So I'm going to write a document for both of them. Removes a doodad by object reference. And this removes the first doodad with a matching name in the array. From the array by object reference, removes the first doodad with a matching name in the array. Well, let's actually make it removes all doodads with a matching name in the array to be more consistent. We'll look at removing just one later, since that's more complicated. Alright, so instead of doodads of I equals to remove, I now have name to remove instead. So how do I modify this line here to support removing one by name instead of removing it by its reference? So how do I modify that line? What should that line become? Either chat, if I want to remove it by its string name rather than by its reference. There's a little bit of a trick in this question as well. Just a heads up. And remember, I'm going to set it to null again, just like I did last time. So I'll just empty out that spot in the array. Keep in mind that when you set that spot to null, again, it's not like the object is destroyed. It doesn't cease to exist. You've just removed a reference to it. There might still be other references to that object out there somewhere. So in this example, to remove is a reference to that object, and it still exists after you've set that spot to null. You can continue to access properties of that object even after it no longer exists in the array. You just don't have a reference to it in the array anymore. So while you're thinking about how to modify that, I'm going to write one more method. And then we're going to play with this in driver to test it out. I'm going to write a method that gets the sum of all of the doodads in the doodad array we have here. And as before, it's going to complain that we don't have a return statement. I like to put some placeholder there until I'm done writing it, so I'll just put return 0. How do I modify that doodads of I equals to a remove statement in order to accommodate checking which one has a matching name instead of matching them by object reference? Doodads of I dot, and then we have access to name, remember, because it's a public field. Okay, so the answer in the Discord is correct, technically. It is doodads of I dot name equals name to remove. Now the couple omissions made here are that doodads of I still refers to the array. We don't need that on the right-hand side. We just want to compare it to the name that you've supplied as an argument. So if the user is looking for a capital A, for example, name to remove, then it's going to check if the doodad that it's looking for in that loop has the name A, and if it does, then it would remove it. The second mistake here is, remember, I warned you that in Java, equals doesn't always work for string comparison, just like it doesn't always work for object comparison up there. So the better way to do string comparison is to do that dot equals rather than doing the double equals. So just occasionally, it doesn't work for string comparison. And the reason that it doesn't work is something that should be clear to you in a few weeks after playing with this a lot. But I'll tell you now, and you can think about it for the future. The reason it doesn't always work is because it's comparing the references of the strings, not necessarily their contents. And so two different strings can both have the same contents, end up with different references, and that causes them to not properly check equality. All right, so for the get sum, this should be familiar to you as well. You should have gotten the sum of integer arrays before. You've gotten the sum of integer arrays for the first homework even, right? So that's familiar. The only difference between this and getting the sum of any other integer array is that instead of looping through an array of integers, we're obviously looping through an array of doodads here. And that means that we need to access their value in order to get the sum. So this is going to get the sum of the value of all doodads in the array. Not the value, not the secret value, just the regular value. So it's going to be sum, and then plus equal to doodads of I dot value, which we made a public field over here, so we can access it directly. We don't need a getter to do so. All right, this might run us into some problems later. And the reason that this might run us into some problems later is because if we try to call doodads of I dot value on an empty doodad, on a null doodad, we're going to run into an exception. I also forgot to return sum here instead of 0. Common mistake. So we want to add an extra check here. We're going to need an extra check here to make sure that the doodads of I that we're looking at isn't null. So we're going to need an extra check here to make sure that the doodads of I that we're looking at isn't null. If you want to leave yourself little notes like this for stuff that you plan to do later, I like to use the keyword to do. You'll see that it gives it a special color. That's because you can actually jump to all the to-dos in your program using command and Eclipse. And so these are kind of like little breadcrumbs you can follow to let you know all the different things that you still have to do. So we've got a few minutes left. Let's go back to driver and try this out. Just for the sake of making this easier, I'm going to comment out all the stuff that we were doing the other day. So control and the dash allow you to make a block comment very quickly. And then if you select something that's already a block comment and hit control dash again, it will uncomment it. So control dash is good for commenting and uncommenting big blocks of stuff. So just for convenience, I'm going to uncomment it. So doodad processor, I'm going to call this proc A equals new doodad processor. And remember, I have multiple constructor options here. I spelled it wrong, And I spelled it wrong again. Luckily, Eclipse has spell check. We have a couple different constructor options here. Let's hover over our constructor description, and we can see which one it's using. So this creates a doodad processor that has an empty array of doodads, all null. All right, that's fine. Let's try that one out. Let's try to print out the sum of an all null array of doodads. So I'm going to print out their sum here. And I get a null pointer exception. How do I figure out where the error is? Again, it's going to be the topmost one that still appears inside your program. So not null pointer exception. I don't have a class with that name. That's just the exception name. The topmost one is doodad processor line 122. If I click on it, it'll take me there. So like I warned you, trying to access a value that's null is going to be a problem. So you should get used to having to perform this check. It's called a null check typically, and it's something that you have to do a lot in Java because objects can be null. That's not the case in every language, but it's definitely the case in Java. So anytime you access an object's fields and there's any chance at all that it's going to be null, you want to perform a null check like that. You want to check if it's not equal to null and then do the thing that you're going to do. So just get used to having to do this check because you're going to have to do it pretty much all the time when you're working with Java. Alright, so now if we run this, then we're probably going to get a sum of 0, right? Because there aren't any in there at all. Well, let's try adding a new one there. Let's add proc_a.addDoodad. How do I quickly specify a doodad in one line? Well, I can actually do it inside here. I can create a new doodad, name it A, give it a value of 5, give it a secret value of 10. I can do all that in the same line. That's convenient. There we go. So now the sum is 5. Let me do it for a couple. Let me make another one called A with, let's say, a value of 10. And then let me make one called B with a value of 3 and a value of 2. And then I'll make one called C, value of 1, value of 5. So I've made a few new doodads and I've added them to the array. If I get their sum now, first I get a couple of error messages in response to what I did there again with the setter. Alright, so it didn't update the secret for A because the secret was bigger or smaller than the value. The value has to be the bigger one. So in these ones the secret is smaller, or in this one the secret is the same, equal. But ignoring that, the sum should be correct. 5 plus 10 plus 3 plus 1 is indeed 19, so I did get the sum of all the doodads there as expected. Let me try to remove one. So first I need a reference in order to remove it for my one that takes a doodad as a reference. And I can't get a reference if I did this kind of inline declaration because I haven't saved it in a variable anywhere. So let me do that instead. Doodad A. This way I've saved it in a reference rather than declaring it all inline. And now I'm going to try to remove A and see what the sum is. I get 14. You might expect that it should be 4 instead. You might expect that this one should get removed. But they're not the same. They share the same name, but they're not the same doodad. They only share the name A. They're still different objects that were created at different times. One of them has a different value, but they could actually have all the same values. The point is that every time you invoke that new keyword, you're creating a new object. So there could be two doodads with exactly the same values, just different references and different variable names. But let's say I wanted to remove all of the ones that have the letter A as their name. Remember, I added another method there that takes the name instead. So this should remove all the doodads with the matching name A. Let's see what I get when I run that instead. I get another null pointer exception. What did I do wrong there? Remember, doodads of I.name. Doodads of I.name. What if doodads of I is null? then once again I'm going to have a null pointer exception. Now, it is a little bit of an added convenience that you can actually put the null check inside the same if statement, and this will not be a problem. So we see that it runs here successfully. Basically, if this part doesn't evaluate, it just stops right there and doesn't move on to the next half, and then you don't have an issue. So as long as the null check is first, this is fine, and that's how most of your if statements are going to end up looking. So we're going to keep looking at this some more next time, and then we'll try some real-world examples with objects. I'll upload this to Canvas when we're done here. Next homework's going to go up later tonight, and it'll be due next Thursday or Tuesday, depending on how much progress we make next time. And I believe that's it for today, right? Time we got 3:15. Yeah, that seems about right. Wait a second. Wait, what is this? 75 minutes? Yeah. Okay, seems good. All right, guys. Thanks for tuning in. I will see you next time. I have office hours after 4:45. If you still have any questions on the homework, remember that to submit it, right-click on the directory you want to submit, go to Show In, go to System Explorer, find the folder you want to turn in, go to 7-zip or whatever your zip application is, add to archive, make sure it's saving it as a zip, and turn that in. All right, thanks for tuning in. See you next time.